Okay, welcome back. Thank you again for your time and for inviting us to semifinals. My name is Colin Taylor. I'm a former drone service provider, and I'm joined today by Sahan Sabet, doctorate student and ex-NASA engineer, and we are co-founders of Revolute Robotics, the first hybrid rolling and flying robot for agriculture. Did you know that most commercial farms are actually losing money without government subsidies? It is our vision to create a world where farms can turn a profit without government aid. Every year, commercial farms lose billions of dollars due to three main reasons: damaged yield, inefficient labor, and wasted resources. Crop yield, and thus farms' earnings, are lost due to farmers' inability to detect problems like pests, diseases, and nutrient deficiencies before any damage is done. Farms are unable to detect these problems any sooner due to the high cost of labor and inability to gather data on every plant at the ground level, the crucial requirement for early problem detection. Instead, farms collect samples from a few plants to estimate the status of the entire field. And when a problem is discovered, farms treat entire sections of the field instead of only treating the plants that need it, not only wasting money, but creating dead zones that can diminish the yield on future crops. Our robot gives farms the ability to change this by gaining complete control over their data. Revolute's patented hybrid mobility allows it to fit between tight spaces to detect over 60% of threats before any damage is done. Our autonomous, energy efficient design provides up to 4 hours of operating time, meaning farms pay less in operating costs, while for the first time ever, they can collect accurate and actionable data on every single plant in the field. Farms can then treat these problems locally instead of treating the entire field and reduce overuse of chemicals and irrigation by up to 50%. This can all be done utilizing a thermal camera equipped with LiDAR and a variety of sensors to detect stresses such as insects, weeds, diseases, nutrients, and moisture. Furthermore, our robot allows farms to know exactly when and where to treat, plant, and harvest their crops. 4 years of extensive research and over 150 interviews demonstrate that these problems are realized by nearly every farm around the globe. And although almost every farm can reap the rewards, our robot will achieve its highest ROI for commercial farms over 250 acres and fall in the budget of farms grossing over $250,000 per year. Of the 2 million farms in the United States, there are over 92,000 that fit this criteria. We plan to reach this audience primarily by attending trade shows and advertising in popular ag publications, and we will also utilize traditional digital marketing methods as well. So being that we are the first ag robot capable of aerial and ground movement, our main competitors are traditional human data collection, tractors and other heavy machinery with sensors, and multi-rotor drones. Our key value proposition is our ability to gather data on every plant at the ground level, which is paramount for detecting problems before yield and profits are lost. So the base model robot costs around $1,600 to build and will be sold for around $3,500 to commercial farms and drone service providers. These costs may increase an additional $3,500 depending on the cameras and sensors that we use. Customers will be charged a monthly subscription cost of $1 per acre for data analysis, as well as a $120 annual service warranty. The ROI for this product is at minimum 65%, or roughly $40 per acre, giving most farms enough additional income to stop relying on government funding to turn a profit. Currently, we have 3 prototypes capable of rolling and flying, and we are now working on our MVP. This includes autonomy and a solar-powered design that will allow for up to 12 hours of operating time, which we believe can be completed for around $200,000 by the end of the year. We'll need around $500,000 in July of 2022 for startup expenses and a soft launch. And finally, to cover scaling and mass production of 4 different product offerings, we'll need around $1 million in 2024, at which point we expect to break even at a revenue point of around $2.5 million. Our technical team is led by Sahan Sabet, former NASA aerospace and mechanical engineer and PhD candidate with 7 years of experience in robotics and dynamics modeling. Sahan's connections have allowed us to build a team of 15 engineers with a plethora of unique experience who have contributed a total of over 20,000 hours to this project. We're also supported by several amazing mentors, as well as Tech Launch Arizona, the National Science Foundation I-Corps, and the McGuire Center for Entrepreneurship. So with that, I'd like to thank everyone again for their time and open the floor to any questions.